Hello, my name is Mark Jerome, and I'm going to talk about the specifics to heat pump installations. The agenda for this section will cover primary goals and the big five specifications, which are equipment requirements, sizing, system airflow, refrigerant charge, and controls. And these will be in the following slides. The primary goals are to ensure the system performs as the equipment ratings suggest. So those ratings are HSPF and SEER, and they assume that the system is properly sized, has perfect airflow, and the right refrigerant charge. Another goal is to incentivize high efficiency AHRI rated heat pumps that are commissioned to the PTCS standards, and to maximize equipment life. Now I want to talk about the benefits of PTCS to you, the contractor. In customer proposals, you can include PTCS commissioning anytime you have the equipment that would qualify. Add that into your bid. We have lots of PTCS marketing materials to help enhance that bid. We have quality technician training provided by nationally recognized trainers and lots of online support materials for your technicians. Another benefit is additional sales opportunities. We're asking you to put in a higher efficiency equipment, larger margin. Commissioning labor can be included into the bid. Any modifications that the duct system may need to be able to meet the PTCS airflow specifications. Thermostat upsells to be able to meet the PTCS specifications. And then other options beyond PTCS. For example, like a high efficiency air filter. Now I want to talk about benefits of PTCS to the homeowner. Commissioning, that ensures that the heat pump is going to operate at the optimal performance. And these installations will be subject to third-party inspections. I think that's a great sales tool. There are incentives out there. These incentives are there to offset that cost of the high efficiency equipment and commissioning. And then by following the specifications, the homeowner can get a peace of mind that the heat pump will, have longevity and efficient operation. Let's dive into the specifications. So the first one is equipment requirements and selection. And to the left side of the screen, you'll see a little specification, a little red file folder. That's going to indicate that this is a requirement and a specification. So the units must be AHRI certified. PTCS certified system is going to have a 9.0 HSPF 14 SEER or greater rating. There's also some utilities that offer a commissioning controls and sizing measure, which basically you can put in any heat pump that's below 9.0 HSPF and 14 SEER. Some utilities do not offer this measure, so check with your utility before promising an incentive or rebate to the homeowner for this. So this includes single stage, two stage, and variable speed systems. And so if we look at inverter-driven variable speed systems, there's a potential for lower operating cost but there is possibility of higher upfront cost. And under most circumstances, these variable speed systems are going to have a higher HSPF. Now we're going to talk about sizing. Both heating and cooling loads must be calculated. We're going to use some type of ACA approved Manual J software or the PTCS calculator. There are a few other types of load calculation tools that could be used. And remember, heating is typically the dominant load in the Pacific Northwest. And so what we're going to need from you is a load calculation and a balance point worksheet. Or you could use the PTCS calculator, but these must be submitted to the utility with your paperwork. And the specification is all heat pump installations must be sized with a balance point of no greater than 30 degrees. And what this does is it maximizes the efficiency without oversizing. So what do we mean about balance point? Let's cover that in the next slide. Now we're going to discuss balance point. We're going to focus on the graphic to the right. And so the horizontal axis, warmer's on the right, colder's on the left. And the vertical axis starts at 0, and more BTUs the higher up you go. And so as it gets colder, the heat loss of the home goes up. And so that's indicated by that orange line. And then at the same time, the capacity of the heat pump goes down. That's indicated by the green line. So the compressor can heat anything below that green line. And then when the balance point is met, that's the point at which the compressor can no longer heat the home, then auxiliary strip heat is needed. Size the unit so the compressor has enough capacity to heat the home all the way down to 30 degrees. And then it can heat a little bit lower than that, but then we can add that strip heat in. So we want that balance point to be at 30 degrees. Now, little hint, for single speed pieces of equipment, getting lower than a 20-degree balance point might oversize and not be able to dehumidify in the summertime humid conditions. We're also going to have a separate sizing webinar. And the topics that are going to be covered in that webinar are going to be load calculations, and specific to that, key factors in heat loss calculations, duct location and conditions, heat loss calculation tips, and reviewing sizing charts so you can make sure you get the proper size piece of equipment. And then with the sizing side of it, we'll cover variable speed pieces of equipment, the PTCS sizing calculator, which is a simplified load calculation tool. And we'll also talk about sizing backup heat, the auxiliary strip heat, and we'll cover some duct sizing tips and tricks. Another specification is around system airflow. It's important for energy savings and comfort, and the heat transfer, which is really the system capacity. And the efficiency really depends on the airflow across that coil. And so the calculation for BTU output is CFM times the density of air times the temperature difference. So airflow is extremely important, indicated by the CFM. Low airflow reduces efficiency and capacity. Our specifications are needed to have measured airflow of at least 325 to 500 CFM per ton, or meet the manufacturer specification for non-variable speed systems. You must either test the airflow with a true flow measuring system, or identify the airflow using external static pressure CFM lookup tables from the manufacturer. If your manufacturer suggests a different airflow than the PTCS specifications, you can use that value, even if it's outside of the PTCS required 325 to 500 CFM per ton range. There's also an external static pressure of the duct system, and that external static pressure shall not exceed 0.8 inches of water column or 200 pascals. Variable speed heat pump system airflow. The airflow of a variable speed heat pump does not need to be tested, but the installer must confirm that the airflow meets a manufacturer specification. By variable speed, we mean a heat pump system that has an inverter-driven compressor. For variable speed systems, the technician must also supply the maximum external static pressure that's allowed by the manufacturer. Continuing with system airflow, the selection of filters is really an important piece to think about. So all filters are restrictive, but some are more restrictive than others. And if you select a very restrictive filter, you may need to compensate by enlarging the return air duct to be able to meet that system airflow specification. So one of the specifications we have is that the technician must measure the airflow with either a true flow plate or the external static pressure CFM manufacturer's lookup table. And so with the true flow plate, we have discounts available, and we'll talk about that a little bit later. But the ability to measure that airflow gives us the option to be able to adjust that blower speed to really dial in and meet that 325 to 500 CFM per ton specification. And then also you can think about additional equipment cost and labor that can be included into the bid. You know, modifications to ductwork to address system comfort and be able to meet the airflow requirements. You know, you can think of that as a sales opportunity. Estimating airflow using static pressure measurement and airflow tables. So here's an example of an airflow table below. It's used by measuring the external static pressure of the system. You measure in the supply plenum and then on the furnace side of the filter to get your external static pressure. You determine what the blower motor speed setting is, and then you can cross-reference that on the table to get a CFM. That CFM can then be divided by the tonnage of the outdoor unit to get your CFM per ton. Here are the steps to measuring airflow using external static pressure measurements. In Figure 1, you can see you need to drill a hole in the appropriate location to measure the return static pressure with the static pressure probe pointing in the direction of airflow, and avoid drilling into the cabinet if at all possible. You're going to want to measure that on the furnace side of the filter. Then in Figure 2, you can see drill a hole in the appropriate location and measure the supply static pressure, and also have that probe pointing into the direction of airflow. Continuing with steps to measure airflow using external static pressure, we've measured the return static on the furnace side of the filter, and we had 0.28 inches of water column in this example. And we've also measured the supply static pressure. We had 0.34 inches of water column also for this example. Then we calculate the static pressure. We take 0.28 plus 0.34, and that equals 0.62 inches of water column for this example. Next, we're going to round the external static pressure to the nearest pressure in the manufacturer's table. In this example, 0.62 would round down to 0.60. Find where the external static pressure and blower speed setting intersect on the manufacturer's airflow table. 1078 CFM is shown here. Now, to confirm the CFM per ton meets the PTCS specification of 325 to 500 CFM per ton, or the manufacturer specified airflow requirements, we would take that 1078 and divide it by the tonnage of the outdoor unit. In this example, we're going to use 3 ton, and that would result in a CFM per ton of 359 CFM per ton, meeting the PTCS specifications. If the airflow does not meet the specification or the manufacturer's specified airflow requirement, you can change the blower speed and start this process over at step 1. Now we'll cover the refrigerant charge specification. The specification says that during wintertime commissioning, we need to use the temperature split chart shown at the bottom of the page. The chart inputs are airflow in CFM per ton that has already been measured, the outdoor temperature to determine the temperature split. The temperature split on the table is a minimum temperature split that is measured across the indoor coil. This way we ensure that the refrigerant charge is correct. In summertime, or any time that the outdoor temperature is above 65 degrees, subcooling is used, or a manufacturer's method such as approach or superheat. Note that variable speed heat pumps do not need to be tested using these methods, but they must meet the manufacturer's specified charge method. Now we'll discuss controls. Controls are needed to limit auxiliary strip heat runtime and maximize compressor use. These functions are typically set up through the thermostat, and the technicians have the responsibility to meet those specs. We've created a lot of thermostat support sheets that are available to assist with proper setup. These support sheets go into proper auxiliary strip heat control lockouts, compressor lockouts, and test modes to be able to commission the system properly. One of the control specifications is auxiliary heat lockout. So we want to lock the strip heat out any temperature above 35 degrees. This control setup is usually through a thermostat. Sometimes it's through an outdoor unit depending on the brand. And it uses a thermistor, which measures temperature, or it might use a Wi-Fi weather station if it's a Wi-Fi connected thermostat. Comfort won't be an issue. If the unit's sized properly to be able to heat the home all the way down to 30 degrees, locking that strip heat out at 35 and above won't cause a comfort issue. Ducts in outside the conditioned space in an attic or a crawl space, you might want to check the condition of those because that could influence your sizing. But we look at these as potential sales opportunities to be able to add this extra functionality.